Hello and welcome to TidyX episode 21. It's the birds episode. All right. So, TidyX is a screencast where we go through and try to explain how R code works and R concepts. My name is Ellis Hughes. I'm a statistical programmer. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward, and I do data analysis in sport. You can find me on Twitter at OSPPatrick. You can contact the both of us either through our Gmail, tidy_explained@gmail.com, or you can follow and contact us on Twitter at tidy_explained.
Yes, exactly. Yeah, reach out to us. We respond. We love it when we interact with people and get feedback and all that. So comment below, add us on Twitter. We'll get back to you.
There you go.
All right. So this week's Tidy Tuesday data set that we're going to be going through is on palmerpenguins. So that's why it's the bird episode. So this is a new data set that it's new to CRAN. It's on penguins around Antarctica. So it's a lot of fun. It's supposed to be a very introductory data set, right? So it's to provide tooling for a data set for people to just kind of play around with and do practice their basic statistics, right? It's the goal is to kind of eventually replace the iris data set. And so lots of people did lots of great posts this week. We're going to actually start with how we approached it first. So let's open this up. All right, so Patrick went through and started doing an analysis, and so we thought we'd take you through the steps that we do for processing this sort of data, how we see it.
Yeah, I thought this was a cool data set. One, because it needed no data cleaning, which is always great, because it means you can kind of jump right in and start doing stuff. And then two, I think, like you said, it's a simple data set with a few easy to deal with variables that have some relationships. And because of that, like you said, to replace the iris data set was like the data set that most people learn their first kind of stats computing on, because it's simple and the relationships here are simple. And so a lot of the plots from Tidy Tuesday this week were what I would call statistical plotting. So rather than bar charts and things like that or simple relationships, people took it a step further to try and statistically describe the relationships, either through something like correlation or regression. Different types of general linear models.
The number of decision trees that I saw this week.
Yeah,
it was great. I was like, this is amazing.
Regression decision trees to figure out bill length from flipper length and all those kinds of things. So I thought it'd be cool to show some different tools that you could use for statistical plotting, in terms of making things a little more interactive, so you can investigate your data, and play around with it.
Yeah.
So the four main packages that we're going to use are Tidyverse, as we always do.
Love it.
Yep. We'll use Plotly, which we've used a number of times before. We'll use SkimR to basically check our data set, even though we just said it's a pretty clean data set. You'll see how valuable that is. And then obviously we're going to use Tidy Tuesday R to load the data, because that's what we do.
That's how we do.
That's how we do it. And then theme set light, because why not?
Because we like that light beam.
Because we like the light theme set light. So
all right.
Today's date, or Tuesday's date.
Alrighty. So here we go. We loaded in the data. Here's the README that's available. It's got a quick little summary of everything that's going on there. We're going to skip ahead. And so what we're going to do is, there's two different data sets that are available this week. Penguins, and then there's a different one too.
It's like location.
Penguins raw.
It's like a penguin's location. Yeah, it has more location-based data.
Yeah. We're not worrying about that one this week.
Yeah.
So we load it in, we read out the penguins data set out of the twos data and assign it to P, because we like P, and it's a good variable to use, and then do a quick head to look at the data set that we've got going on here. So it looks like there's eight columns here: species, island, bill length, depth, flipper length, body mass, sex, year. So, it's just a couple variables. Pretty easy for us to understand and wrap our heads around what's going on there.
Good combination of numeric and kind of categorical variables and things like that.
Exactly.
So just some simple exploratory data analysis, as I always do when I first sit down with the data. The skim function here from the skimr package is a great way to get just a quick check of your data. So similar to anyone who's used the psych package for basic stats and run describe or describe by, the skim function here gives us just a huge, rich amount of information about the data in terms of rows and columns and a number of character and numeric variables, information about what's missing or not missing, and some information about some basic summary stats like the mean and the standard deviation, the quantiles, everything from 0 to 100, obviously P50 being the median, and then a cool little histogram there that just gives us kind of an idea of what the distributions actually do look like.
Yeah.
And we can see right there, n missing. There's 1, 2, 4, 6, 8, about 8 variables missing across the numeric and about 11 in the character data. Right. So we have about 19 NAs in this data set. I don't know if they're all coming from the same rows, but I think most of them do. So we'll handle that in the analysis.
Yeah.
And just get rid of them because we don't know why they're missing. So
it's not useful to us.
Yeah, exactly.
It's what, missing not at random or missing at random? We're assuming they're at random at this point.
Right. We don't know. So just kind of a count of, obviously, there's more Adelie species than there are chinstrap. So if we were going to do any sort of classification, we might have to be aware of that. I start out with a pairs plot, and this is one of my all-time favorite plots. It comes from the ggally package, or ggally, I guess.
I think it's
ggally package. Is it ggally? Okay.
I think so. I mean, everyone's like GG something.
Yeah.
So I'm just.
This is an awesome plot. I used to do this in base R, and I'd have these massive functions to be able to create it, and they never looked great. And this is like a super simple function that works with ggplot2, and it's awesome. So you use the GG. Well, first I take my data set and I select the columns that I'm interested in. So numeric, and then I also select gender or sex because I want to graph by that within this pairs plot. The NA omit is just basically telling our, hey, if you find any rows that have an NA, just get rid of them. So you just have to be aware of that. I'm not going through and doing anything specific. So if a row has like 1 NA, everything in that row is gone. So you just have to be aware of that.
Yeah, I mean, it's pretty common for this sort of behavior in modeling and whatnot. Like LM, I believe, does this, and you can define the way it's supposed to behave as well.
Correct. Yeah.
But it's
action.
Yeah, but it's pretty useful to not have to like do your own filtering. You just like, okay, R, get rid of it.
Yeah, get rid of them. Yeah. So the first thing I do inside of ggpairs here function is I select the columns that I'd like to plot my pairs plot against. So I basically just take all of the numeric columns. And then the mapping here is that I want to color them by sex. So I want to make sure that there's a differentiation in the colors between genders so that I can see if any of those 4 variables have any sort of signal between genders. And so we go ahead and we run this, and it's going to produce this super cool plot that gives us a ton of information straight away. So histograms in the diagonal, so we can quickly see, again, colored by sex, so we can quickly see that the females are in that reddish orange type of color and the males are in the kind of Aquaman green color. We also get it by dots in the lower triangle, and then the upper triangle provides us with the correlation for the population, and then the correlation stratified by our groups that we specified. So in this case, male and female. So it's a really nice way of quickly kind of grabbing some information. Now, one thing you'll notice in the points plots on the lower triangle is that there's sort of these clouds that are pretty distinct. You can sometimes see 2 or maybe 3 clouds that are distinct. And initial hunch is that that's probably due to the 3 different species. So we're going to go ahead and produce a pair plot, this time coloring based on the condition of species, so we can identify those differences and wrap our heads around what the data looks like.
Yeah, so this is the same exact code that he was using before, except now now we're keeping the species field there.
Yep.
Right there. Same NA omit, getting rid of any NAs. Same stuff, except now you're coloring by species.
Yep.
And sex is now one of the columns you're using.
And so that's right. I put another categorical column in there. And so that's going to give us a box plot.
Yep. So it's running. We got that. And boom.
And so here we see, again, we have our histograms down the middle, with the exception of sex has that kind of bar plot mixed by species. And then we have our correlations in the upper right triangle, the upper triangle. The far right column has our box plots, which are going to be colored by species for male and female. You can see on the x-axis male and female. And then we get kind of these cool histograms at the bottom and our dot plots. And you can see now very clearly from the gender plot that we did before, you can see the differences. So obviously this is going to lend itself to things like, teaching people how to do k-nearest neighbor and classification tasks. And, if we see a new penguin with a bill length and bill depth of this and a flipper length and a body mass of that, what's the probability that they fall into one of these 3 groups? So pretty cool. These are like one of my all-time favorite plots when I start out an analysis, just to kind of get a sense of what the data looks like and where it is.
Yeah, exactly. This is just so information dense at this point here. You can start coming up with ideas of how you want to model this data or how you want to approach this data and looking at, okay, well, clearly flipper length, blue, Gen 2, they are usually, much larger or much longer flipper length than the other ones. So that might be a way.
Much less bill depth.
Yeah, right? Or bill length, and then much less. Yeah, Gen 2 has a much smaller bill depth, but then also bill length here. The Adderley tend to have a smaller bill length, so that might be another way to differentiate those two. And so you can kind of like start figuring out ways and start looking for signal in your data there without actually having to do anything other than just look at it.
Yeah, super cool.
Yeah, cool.
So we see some relationships there within the data. This one by species we just
did that one. It's because I zoomed in, so
there we go. Yeah,
the scaling changed.
We saw some relationships there with the data, so I figured, what if we allowed ourselves to interact with the data a little bit? So here's where we use Plotly. So the first thing I do is I create this element called dat, and I put in this highlight key P around P. That's our data set is P. So that's going to allow us to highlight things within the plot that we're about to see. Plots a bunch of information. I created a base plot in Plotly. So I'm basically taking that dat element that I just created. I'm going to start out with the color black, and you'll see that we'll have a number of options. And then I put show legend false just because sometimes the legend can get dirty on these things. It's a lot of stuff. And then I create my plot. So the subplot is basically saying I want a number of different plots kind of arranged in different areas. So I do a little kind of a dot plot, add markers there to the base plot, bill length by bill depth. We had a box plot next to that based on gender and bill depth. And then we add, at the bottom of this plot, this add trace is going to give us these column or geom calls or geom bar plots, rather, bar plots. And, this was the violin plot. The next subplot is the histogram plot.
So you're adding a trace of type violin. So it's saying, okay, add a layer that's a violin.
Yep.
Add these markers and share Y.
And then the add markers is going to put the dots on the box plots and the violin plots. And then the subplot, add histogram, is going to go at the bottom. We want this by species.
And then we're piping it into this. So all of this subplot before is now going to be like contained within this subplot here.
Yep.
And now you're doing add rows too. So now all of this is going to be on one row.
Yep.
And then this new histogram is also going to be on its own row.
Yeah, and we specified the number of rows right there.
Mm-hmm. So layout, overlay,
Yep.
and then highlight whatever we've selected.
Yep. And then dynamic equals true. So when we run this,
Hold up.
oh, we got to
What did I
run
do?
there we go.
That's on me. It's the spacing that I put in there.
So now, as I said, we started with black, and we get a cool kind of look at our data. And now if you highlight something, like, for example, hover over, So this is really cool, right? So you can clearly see the points that you just outlined are clearly only part of the Adelie penguins. And you can see that they also contain a larger portion. I think for the male and female box plots, we were doing things like bill depth or bill length. I think if you hover over the colors there, right? They are mostly towards the top of that distribution. We can change the colors on brush color. So if you go and change it to like green and hold down the shift button as you highlight, we can get a second. We can get a second color. And so now we can see how different groups overlap or share qualities or maybe are incredibly different, right?
Yeah, that's tricky.
Pretty cool. Yeah.
That's so cool.
So then you could put like blue on there. You can change it to a different color. You got to click brush color.
Oh.
Yeah. Purple, yeah, and then do another highlight, holding shift. Get a few of those. And so now we can see.
Look at, like, these two.
Yeah, we could. I think we could have done some labels of what what's on those actual axes when you roll your cursor over them. But pretty cool though. Just an easy way to kind of look at your data. And so after I did that, as a way of kind of like investigating the data, I said, okay, well, we see some linear relationships in this stuff. So why don't we go ahead and just build a really simple linear model where our dependent variable is bill depth, I think it was.
Did I go too far?
Yeah, you want to go down.
This one, statistical plotting.
Yep, and then go...
To this guy right here, right?
No, go up, sorry. Oh, yes, you're right, sorry.
It's the zooming in and out that like,
yeah.
And then the scaling of the...
So the statistical plotting here, we start by plotting the regression line. So again, we create that dat element, and now I literally just build a ggplot. So within this ggplot, we're going to be plotting bill length on the x-axis, bill depth on the y-axis, colored by species. We're going to ask for geome point, and so I tell it a size and alpha, so there's some opaqueness to it. And then geome smooth is where we get our regression lines. That's why I use method equals LM for linear model, and standard error equals false. So I don't want to put the standard errors around it. You, of course, could. I just chose not to here. Facet wrap by sex. So we're going to break this out by gender. And then a little bit of niceness here, theme. I'm going to make the male and female gender, the two squares where they're broken out. I'm going to color the background black, and I'm going to color the text white, make it bold, and I'm just going to ditch the legend because we don't need it for this plot. And so that's an easy way of making a ggplot, and then all we do is we wrap it in the ggplot function, and then we tell it that we want to highlight when we hover over, and this is a pretty cool way to see what these relations look like. So for example, in the females, in the relationship between bill length and bill depth, we see that they all have a positive relationship, and they're all kind of maybe with the blue. The Gen 2, maybe that relationship is a little bit stronger than the other two. The slope is a little bit steeper than the other two. For the males, it's a bit different of a story. So for the Adelie penguins, there's really no relationship. It's kind of like a horizontal line there. Whereas for the chinstrap penguins, there's a much more steeper slope, so a stronger relationship. And then for the Gen 2, it's slightly less. So if you were going to model this in any sort of way, you might want to take those kinds of things into consideration. This is a great way to just explore the data and look at that.
Mm-hmm.
So then we can go ahead and we just build a simple model. And so we build a linear model, and I call it fit. And I'm building a linear model on build depth with the independent variables of flipper length, species, and sex. I'm going to get it from data P. And again, I'm just going to remove the NA values to make things simple. You don't have to. LM will do that for you, actually.
Yeah, I think it's NA action right there. Boom.
NA.action, yeah. You could have done it like that, correct. Equals NA, yeah.
Is it just like that? Let's run that.
Yeah, I think it is.
It ran.
Normally we would look at fit by doing summary and then putting the summary function and putting fit into the function. This is a really busy code with lots of things and stars in the right column and significance codes and p-values and lots of stuff. So usually I tend to use the ARM package, which is written by, I believe, Andrew Gelman and his colleagues. He's a stats professor at Columbia. And they have a function called display. And you can feed it the number of digits you want to see. You run this function, and it takes the key things that you need to know. So coefficient estimates, coefficient standard errors, get rid of the p-values and the stars. So this is much cleaner to look at. We have, obviously, the n, our sample size. We have the number of predictors within there, the residuals, and R squared of the model. It basically gives me all the things that I kind of need to just look at, right?
Mm-hmm.
So, super nice.
Exactly. It cleans it up a little bit, reduces the amount of noise that you have in there.
Exactly.
Because you can get distracted by all that other stuff there.
Exactly. And then we can plot this in an interactive way. So if you looked at that display, you would see that the coefficients some are big, some are small. The standard errors are large and small, so they're on different scales. And so if you were to just plot these as a static plot, as you'll see, you'll have a lack of appreciation for where the confidence intervals actually are. So what I did was I used the Broom package from David Robinson, who was on the show last time.
I think it's actually it's moved out of his. He came up with this. I think he came up with this idea, which is a beautiful, amazing idea. But I think there are other people that are
other people are doing it.
Have continued this great work.
Yeah, exactly. So I take the Broom package, I use the tidy function, and I wrap fit in that. That's another way of cleanly looking at actually the data from a regression equation if you were to just run that.
Yeah, it's right here.
Boom. Oh, there it is. Yeah, boom. So estimate, standard error, the test statistic, and then the p-value. So it's super easy to see. I'm going to filter out the intercept term because I just want to look at the coefficients of the model, the betas. We're going to use Plotly on the x-axis. We're going to print the estimates, so that's the actual coefficients, and then we're going to put on the y-axis the term, so this is going to be kind of a horizontal plot. And we're going to add markers. I want error bars for the standard errors. We could have done 2 times standard error and gotten confidence intervals, 1.96 times standard error. We're going to color it black, and hover info is going to give us info when we hover over it. So we run this, and we get a plot of our coefficients. So like I said, something like flipper length has and chin strap, those have really small coefficients and really small standard errors. So it's hard to appreciate those when something like species Gen 2 is in the plot because it's on a different scale. The magnitude is so much greater. So we can hover over and we can actually highlight and drill into, for example, the flipper length and start to get an appreciation for where that confidence interval is. And like I said, we have it set to hover so you get the estimate plus or minus the standard error. So that's a super easy way of, and then double clicking obviously will take you back to your original model or your original graph. And so that's a great way to get into plotting regression equations, estimates, and looking at them and drilling down into them. And it's particularly useful if you have a model with lots of estimates that you really, want to kind of look at, all at the same time and drill into each one.
Exactly.
So that's a little
There you
bit
go.
on statistical plotting with the new penguins, Palmer penguins,
Palmer penguins.
Palmer penguins data
Yeah.
set,
I
which you
think,
said is available now.
yeah, it's available on Crayon. It's by Allison Horst. I think she's the one that threw it up there. And she also has got some wonderful, wonderful drawings and cartoons that she's drawn of the penguins themselves. Like you can see
Yeah.
that if you, let's see, what was it? Two's data.
Yeah.
Like she drew these. Like she's drawing a lot of like these fun animations all across. So like call out to her for drawing all those things. 'Cause they're so fun. They just make it fun.
Yeah,
I think,
super cool.
to go through. She's doing it all across like our stuff. So it's super fun.
So easy data set to work with. No real cleaning unless you want to remove some NAs, but also a great opportunity to practice imputing values. Maybe we'll do a screencast on imputing values for the NAs sometime and the different methods that you can use. But yeah, easy data set to work with. Get some quick, kind of bust your chops working on some graphics and doing some statistical models. Good stuff.
There you go.
All right, guys. Well, we are back on day 2. Sometimes life gets in the way, and we both have full-time jobs. So this week we actually split up recording the guest post and then our own. So we did our own first. So now we're going to go back and do Roman Links post here. Ours we had used ggally to plot a pairs plot, which is basically a correlation type matrix that gives us a great way to look at the data in from a number of different senses. And Roman's tweet, as you can see right there, is really cool. He created his own package right there, Corrmorant, which is
2 R's. 2 R's. Corrmorant. I think that's pretty clever.
Yeah. So created his own package. It's a work in progress, but it's really cool. And actually, I believe it works like specifically on this penguins data set, doesn't it? It has like some features specifically for this.
I mean, he worked on it a little bit to try to make it look pretty cool with this one, because this is like the first time he's actually used Cormorant and shared it out to everybody.
This was the maiden voyage.
Yeah, and so like, I was happy to see this. I thought that was pretty cool. I mean, apparently a lot of people like this. With 183 likes, 30 retweets and comments. So apparently the rest of our universe liked this as well.
Yeah, and I think the exciting thing as we get into this is that if you look back at what we did, we used ggally, which is a pretty kind of what I would call like block and tackle type of package. You kind of get what you get. This has a lot of extra features where you can kind of customize the upper and lower triangle and the diagonal and do all sorts of things. So why don't we hop into the code and check it out?
Yeah. He's got a link to his gist where he kind of demos how to use it here. He's also got a link to his actual package here, which is at r-link/Corrmorant on GitHub. All right, so we've copied his code over into our R studio session, and I guess we'll just jump into it. All right, so the first thing you have to do is you don't have it, which is probably a high probability, is you have to install it from GitHub. And so the best way to be doing that is using remotes, the remotes package, and install _ GitHub. You name the name of the user or organization and the actual name of the repository, which in this case is r-link/Corrmorant. So we've already installed that, so we don't have to run that line there. And then the next we have Pacman. So Pacman is a package that helps people with loading and managing all the different libraries that they've got going on, and tries to like speed things up for you, so you don't have to spend time reloading and re-downloading a ton of stuff. So this function here, p_load, what it does is it'll check to see whether you have the library in your computer, like basically already installed, and if it does, it'll load that up. It's a cool, awesome, you've got this. But if you don't have it installed, it'll install it. It'll try to figure out where it's from. So CRAN, Bioconductor, potentially GitHub, and it'll pull that in for you and install it. So you can. This is like useful if you're trying to share out your code with people, and they might not necessarily have the packages installed. This will kind of take care of it for them and basically call library for them, so they don't gotta worry about that. So let's run that.
All right.
So now we've got it all loaded, and so now we kind of get into the actual processing, which thankfully, because as we've said in the earlier sections, is such a clean data set, you really don't have to do all that much to it. So first he defines some nice colors that he wants to be using. So these are the hex codes for various colors that he's decided, and he's assigning them to a few different objects there. So ice, so that'll be like a bluish color, beak, which is kind of a yellowish color, sky, and feather. So run those so those exist. And now we'll hop into, so basically the bulk of this code is just showing us how to use Corrmorant. So the first thing is he's taking penguins and he's going to remove the year because when he created this example, year didn't exist in the data there. So when we first played around with it, it didn't work, and it's because we didn't quite understand what we were supposed to be doing. He didn't expect there to be year in there, so he's dropping that off so he didn't have to change the rest of his code. So drops off year, and then we get into the actual setup of ggcormorant. So ggcorm appears to be like the workhorse package that lives inside of ggcormorant, where see now first he's setting his aesthetics. So as we do with basically all ggplots too, you have to set the aesthetics on how it's supposed to be interpreting the data that goes into it. So you set the color and the fill. So he's using an abbreviated, so this typically you want to be writing out OUR or OR, it depends on where you are, color and fill. So we'll leave it as he had. The next thing is labels. So the key to, at least how we understand how ggcormorant is supposed to behave, is it automatically, if you pass it a matrix or a data frame, will reshape the data set so you can look at all the numeric columns and automatically perform the comparison between all of those. And so what he's doing here is he's defining the labels that he's going to be assigning to the numeric columns. And if we just do a quick peek at this here, let's actually send this into a str structure. So the numeric columns that exist inside of this data set are build length, build depth, flipper length, and body mass. So, and those are the only numeric. Integers are kind of like numeric values there, and so you can see that that's listed in the same order here. So Coleman is another word for Bill. Coleman length, Coleman depth, so that matches these two here, and then flipper length and body mass. So that's flipper length there and body mass there. So those are the nice names that he's going to be that get assigned on the printing of this data or of this plot here. Then he sets the backgrounds of the different panels. So this has got it's a 4x4 panel plot, right? So it has 4 different panels going vertically and horizontally. So he's setting the backgrounds, and so the diagonal, so BG dia, uses this hex code for the background color, and then BG lower triangle, not low tree as I first thought it was. I'll own up to that. He's using this hex code, and he's using the same one for the background of the upper triangle. Okay, so this is like just super basic. It doesn't actually plot anything yet. At this point here, we can just take a quick peek. This is just kind of setting it up. It's a canvas.
I think it does actually also, though, underneath do the math. So I think the ggcorm function, aside from running some of these kind of ggplot stuff underneath, will do, it starts the correlations, because I believe in that function you can specify whether you want a Pearson or a Spearman rank correlation or a Kendall's tau correlation, which is another type of rank correlation. So I think you can actually specify as an argument within ggcorm the correlation type that you want. I believe it defaults to Pearson. So core method. There it is. Yeah.
So that'll change how it behaves.
So it's basically running base R's core function to get those 3 options. So it doesn't do any categorical variables like a phi coefficient or something like that.
Mm-hmm.
Just numeric variables. But those are
Yep.
your options.
All right. Do you want to explain what's going on in this lower triangle here, so we can
Yeah,
click?
so this is one of the cool things about this package. Like I said, ggally, you kind of get what you get. This allows for a little more customization. So low tri is, as the name would imply, the lower triangle. And the first thing he's basically saying is what kind of geomes. So just like any ggplot that we've made in the past, which is pretty much all 22 episodes, we use ggplot. You specify which geome you want in that lower triangle. So first he does geome smooth. And so he's basically giving it alpha, which again is something for transparency. So 0.3 is going to be it's relatively transparent. The method is going to be a linear model. So it's going to be a straight line. And then the size of the line is going to be 0.3. And then he adds in the points. So this is an interesting one. In ggplot, I don't think, even though we've used ggplot for 22 straight episodes, I don't think we've ever talked about it. The ordering or the layering of your geomes actually matter. And so one goes on top of the other. And if you can remember any time that we've ever done a line over points, we always do the points first and then the line. So basically the line sits over top and shows the relative trend of the data. So in this case, he actually flip-flopped it. So the line is in the background and the points are on top. And there's nothing right or wrong about it. It's just an interesting thing to bring up that we haven't previously done.
Mm-hmm.
Similar alpha 0.3, so there is transparency, so you'll be able to see the line behind it. And then the size is going to be 1.
Mm-hmm.
Yep.
Cool. All right, so then he goes and starts defining what's going on in this upper triangle. So we've got the lower triangle of the correlation plot there, like this bit here, and the next we're going to be doing this upper bit here, the upper triangle. Mm-hmm. And so first thing he does is add the cortex, so the correlations that were calculated between the two, between two those two numeric values there. He adds those in there, and so that's what this line is doing here, and it's I believe it's then impacted by the method that you use here, and so by default you use Pearson, it looks like. Next he's adding to the upper triangle. He has a special geom that he's got, which is geom rel text. And so what we were able to figure out from this is you're able to set your aesthetics here, so the relative x and the relative y. So this will help you, so you don't have to know exactly where you're supposed to be placing it in like the general geom or the GG object. What you can do here is you can use the relative x and relative y. So this is within the panel itself, how do you want it to be shaped? And I'm assuming it goes from 0 to 1, horizontal, or basically for your x, and same for your y. And so he then has this data that he adds here, which he creates right here. And so this is a relative x, so along the x-axis, place it 0.77 of the way through there, and then rel y, put it a quarter of the way up. So it's basically going to be plotting it whatever label he wants to be using there. So he's got this label here in the lower right hand quadrant of that the panel there, and he's using this this weird looking string here. That's actually Unicode, which I don't know if all the time ggplot is able to understand it, but I'm assuming this geom comes with a way for it to interpret the Unicode, and it's actually a penguin emoji. So we can quickly go over to this, and so this is what it might look like. So Unicode kind of depends on the operating system you're on, so it could show up kind of as that penguin little head down there. It can show up as this penguin here. There's a lot of different ways that it can be viewed, but that is generally understood as the penguin, like that string of characters there is known as the penguin Unicode. So he's going to be drawing it there. It's going to be size of 10, and it's not going to inherit any aesthetics there because he wants it to show up exactly the way it is. So now he's got the correlation text kind of around there, and then to make it a little bit cuter, he's got this this penguin emoji showing up there and all the quadrants there. So awesome. That's fun. And then here is where he's defining how the diagonal. So now we've done the lower triangle and the upper triangle, but as we know that there's always going to be that the diagonal where it's comparing against itself. And here you can use it to show the distribution or how the actual value that you're looking at behaves. So do you want to take us through this, Patrick?
Yeah. So here, the first thing after the die names is color white. So he's going to basically tell you what he wants it to look like. And then density is he's asking for a density plot. And we've made those before. I think you can change that to histogram if you wanted. There's a number of options that he kind of gives you there. Looks like 3 options for right now. Maybe he'll be adding more, but he left it as a density plot, which is really cool to look at because he had the I think at the top the labels as species, or sorry, fill as species. We're going to get 3 density plots, and so that's why he also passed it that alpha of 0.4, so that there's some transparency, so you can see the different histograms behind each other or behind the top one, and have an appreciation for the differences between the distributions of the data. And so that's going to be running across the diagonal. So that's going to explain the variable, the 2 variables that we're comparing. So you'll see them in the upper and lower boxes above or next to the diagonal. Mm-hmm. Then he goes into scale color manual, which is everything from here on out is basically making things pretty. The values he specifies are the ones that we had specified all the way up at the top right there where he used the hex code. So that's our sky, beak, feather. And the aesthetics are for color and fill. And then the theme, which is something that we do all the time, again, making things nice and pretty. He's specifying the plot background that he wants and the legend background. So those are going to be all rectangles that basically the information is sitting atop of. So he uses element rect and passes hex codes that he is interested in. It looks like there is a standard theme to Corrmorant, and he is modifying it probably because of the colors that he chose to specify, so they kind of pop out a little bit more. Axis text is going to give you an adjustment to both of the X and Y axes. Obviously, you could do axis text .x or .y if you wanted one to behave a certain way versus another. But axis text by itself is going to address both axes. He's setting his color to ice. The strip text, he's setting his color to ice also. Then the legend title, he wants to be blank, so he doesn't want a title over top because it's just going to say species, and we know it's species by the names. The legend text is going to match that of the axis text, which is going to be ice again. And then the panel border is, so the panel background is going to be the stuff behind. The panel border is just going to put a box around it. And here he is saying, give me a rectangle. Don't fill it because I just want the square. And size 0.6, so it's not going to be as thick as the default, which is 1. And then the color is going to be ice, which is the same as the text color for all of these axes and legend and things like that.
Okay. All right, cool. So let's run this.
Give it a go.
I moved things around, so I've got to run it from the top there.
There we go.
It's a known RStudio issue. All right, so... All right, let's just zoom this out so that it looks a little bit prettier. Boom, there we go. And there's...
Hey, we created it.
There's so now, the same thing there.
Yeah, and again, you have kind of a cool... so again, if you think about the ggally one that we did, like, look at the correlations in the upper triangle. They actually change size based on the magnitude of the correlation between the 2 variables. So we can see, for example... Coleman depth and Coleman length have a correlation of 0.65, and that is much larger than the 0.39, which is the Coleman length and Coleman depth for the Adelie species.
Versus chinstrap, yeah.
Versus chinstrap, correct, yeah. So pretty cool. And then on the bottom triangle, we see kind of our linear models that are printed out. So we have the lines. I think in ours, we got rid of the standard errors, but he left them. So you can see your confidence intervals. Ours, we put standard error false. Here, he left the confidence intervals that sit behind each of the lines. So you can see the 95% confidence interval is the default. Mm-hmm. And And then across the diagonal, we have cool kind of histograms where you can appreciate the distributions and some of the differences between those distributions. So pretty cool plot. Like we said, these are great plots for fitting a ton of data into like one single view. So it's a great way when you're just kind of exploring your data to figure out what's there. So Roman link, the package is called Corrmorant. It's super cool. It's just kind of, like I said, this was its maiden voyage. So we're happy that Roman allowed us to check it out and kind of give it a test drive, and hopefully you guys will enjoy it as well.
For sure. Yeah. Thank you, Roman, for letting us go through and explain your code, explain our rudimentary understanding of your new package. We're looking forward to seeing how it's going to develop and, impact a lot of people, because, the reason we all develop packages and whatnot and share it out is to help people learn how to do things better and faster and make cooler plots. So, and this is definitely a cool way to approach all this. So thank you so much for all this, and thank you also for everyone else for listening to us go through and explaining how this works. We've been really enjoying doing this, and we love to hear from you. So if you have any thoughts, comments, suggestions, leave a comment below, or you can also reach out to the both of us two different ways. You can email us at tidy.explained@gmail.com. Or we have a Twitter. We started that up a couple weeks ago, so it's tidy_explained at tidy_explained, and you can get in contact with both of us, and we'll get back to you on any comments, thoughts, suggestions you have on there. So I think that's it. We're gonna close it off. So as always, my name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward. You can find me on Twitter at OSPPatrick.
And keep on exploring your world. Take care and keep safe.